Jay and his wife Kaz are having a party. Jay has invited 5 friends, and each friend will bring his wife. At the beginning of the party, the 12 people stand in a line for a photograph. How many different arrangements are there of the 12 people if Jay stands next to Kaz and each friend stands next to his own wife? Okay, so now the pairs need to be together and we have 6 pairs. So we will be arranging these 6 pairs and not those 12 people, but 6 pairs. 6 pairs have an arrangement of 6 factorial. Okay, but that is not enough. Now, every spot will have another 2 arrangements because either the husband is on the left and the wife is on the right, or it's switched. So, every arrangement will also get multiplied by 2. So, into 2 power 6 or 2 factorial power 6, it's the same thing. So, this will give us 46080. Part 2. How many different arrangements are there of the 12 people if J and Kaz occupy the middle 2 positions? So this could be J and Kaz or Kaz and J. So that would be 2 factorial. And if J's friend, hold on, how many different arrangements are there of the 12 people if J and Kaz occupy the 2 middle positions in the line with J's 5 friends on one side and 5 wives of friends on the other side? Okay, so the friends need to be, that is, the males need to be on one side and female need to be on the other side. So we'll have maybe 5 males here and 5 females here, or it could be swapped as well. So 5 males is 5 factorial and 5 females is 5 factorial. And since they could swap, male could go towards the right and female could go towards the left. So another 2. Okay. So 5 factorial into 2 factorial into 5 factorial into 2 factorial, or just 2. So 57600 would be the answer. Part B. For a competition during the party, the 12 people are divided at random in group of 5. 1, 2, 3, 4, 5. 4, 1, 2, 3, 4, and 3. Okay. Find the probability that J and Kaz are in the same group as each other. Okay. So we have 3 cases. Maybe J and Kaz are here, or maybe they're here, or maybe they're here. We'll consider all the 3 cases. Okay. And then we'll divide that with the total number of outcomes because this is probability. Okay. So let's say J and Kaz are somewhere over here in the group of 5. So that will be 2C2 for them. And now we have, there were total 12 people. So now 10 people are left. And out of those 10 people, we have 3 seats available here. So it's going to be 10C3. Okay. Now we have seats occupied or group or places occupied by 5 people. So next we're left with 12 minus 5 is 7. So this would be 7C4. And now we'll be left with 3 more people and these 3 spots. So 3C3. This would give us 4200. Okay. Next, what if J and Kaz are here? So then we'll have, these are 5 slots in total. We have 10 people who could take these 5 slots. So we'll start with 10C5. Why did I not take 12C5? Because J and Kaz, they're here. Okay. Then in the second group, we'll have J and Kaz, so 2C2. And then we have 2 more spots available and we have 5 more people left. So 5C2. And then in the end, 3 people left for these 3 slots. So 3C3. This will give us 2520. Okay. Next would be 10. Next, we'll consider that J and Kaz are in the last group. So again, we have 10 people, out of which 5 can fit in here. So 10C5. Then we'll have 5 people left, out of which 4 can sit here. So 5C4. And then we'll have 2 here, 2C2 for both J and Kaz in this group. And then we'll have 1 spot left for the 1 person left, 1C1. Okay. This comes out to be 1260. Sum these up, this plus this, we get 7980. These are our favorable outcomes. So favorable outcomes would be 7980. What would be the total outcome? We could have 12 people here, 12, 5 out of 12 here. So 12C5. Then we'll be left with 7. So 7C4. And then we'll be left with 3. So 3C3. This gives 7980 upon 27720, which gives 19 upon 66.